Now that you have learned about what container services AWS offers and what serverless means, let's continue our conversation about containers. To recap, ECS or EKS is the container orchestrator. This is the tool that is managing the container's lifecycle. Then you need the compute platform. This is where the containers actually run. Previously, you learned that ECS and EKS run containers on clusters of EC2 instances. And in that case, you are using EC2 as the compute platform for your containers. And you also have tight control over those instances. Now, EC2 is certainly not serverless. So thinking about serverless compute for containers, I want to introduce to you a service named AWS Fargate. AWS Fargate is a serverless compute platform for containers that you can use with either ECS or EKS. With AWS Fargate as the compute platform, you run your containers on a managed serverless platform. The scaling and fault tolerance is built in, and you don't need to worry about the underlying operating system or environment. Instead, you define your application content, networking, storage, and scaling requirements. There's no provisioning, patching, cluster capacity management, or infrastructure management required. To break that down a bit, the way you work with Fargate is you first build your container images and push them into a repository, like Amazon Elastic Container Registry, for example, which is a place where you can store container images for them to be pulled and deployed from. So you have your container images in your repo, and then you define memory and compute resources for your task if you're using ECS, or your pod if you're using EKS. Then you run your containers, and at the end, you only pay for the amount of vCPU, memory, and storage resources consumed by your containerized applications. Fargate does support spot and compute savings plan pricing options, just like with Amazon EC2 instances. So there is some flexibility on how you plan to run containers on Fargate. So you can still get a good amount of control for your containers deployment, but without needing to worry about the provisioning, patching, and managing the underlying operating systems or instances, and no need to scale the infrastructure in and out to meet demand like you do with EC2. As far as use cases go, AWS Fargate can be used for all of the common container use cases, including microservice architecture applications, batch processing, machine learning applications, and migrating on-premises applications to the cloud. All right, hopefully you now have a 10,000-foot view of AWS Fargate. You can see how Fargate is an example of how serverless simplifies your operations and management for running scaled container solutions.
Looking back at the architecture diagram for our application, the part we want to focus on for this section of the course is this part, the network, or VPC, and its many components. But before we dive into networking on AWS, let's first put this into context. In a lesson you saw earlier, we launched an instance and connected to that instance over the internet. But to launch this instance, we needed to select a network. How you configure this network, or VPC, is actually what helps enable internet traffic to flow into your application. You might be asking, Seth, how did we select a VPC when we haven't even built a VPC yet? You're right, we haven't built a VPC. But fortunately, AWS creates VPCs for us in every region by default. When we launched our EC2 instances earlier in the course, we simply chose the default VPC. These default VPCs are meant to provide an easy way for you to get started with EC2 instances quickly and view your applications over the internet. However, you have to be careful with what you put inside of these default VPCs, as those resources will be subject to, well, the internet. And with internet access comes potential dangers. If we didn't select this default VPC, we would have needed to select a VPC that we custom built. In this section of the course, we'll focus on doing just that, building a custom VPC for our application that is more secure and provides more granular access to the internet than the default option we originally chose. While viewing this section, keep in mind that this information is geared towards EC2-related services. If you are using a different kind of compute, such as a Lambda function, you might not need a network at all. However, that doesn't mean this isn't important. Networking on AWS is the basis of most architectures, so consider this information highly valuable. Coming up, we'll dive into some key VPC concepts. But for now, take some time to review the upcoming notes, which will cover some important networking basics that you should know before jumping into networking on AWS. In this video, you'll be learning how to create a VPC with Morgan's help. We'll both be conceptualizing and building a VPC throughout the next few videos. The idea of a VPC is similar to how you think of walls around a data center. In a data center, walls act as a boundary between the outside world and all of your infrastructure. A VPC in AWS acts the same way. It creates a boundary where your applications and resources are isolated from any outside movement. So nothing comes into the VPC and nothing comes out of the VPC without your explicit permission. When you create a VPC, you have to declare two specific settings: the region you're selecting and the IP range for the VPC in the form of CIDR notation. For our VPC, we'll be locating it in the region where the rest of our infrastructure will be, the Oregon region, and our IP range we'll say is 10.1.0.0/16. All right, so currently our VPC looks just like a box. Time to build the VPC. Okay, Morgan, let's build out a VPC for the employee directory app. I was hoping you could build us a VPC that matches this diagram.
Sure, let's do it. If you're looking at the console, you'll first check to make sure that you're in the correct region by clicking on the upper right-hand corner. Seth mentioned we're going to run out of the Oregon region, so we'll go ahead and make sure that this says Oregon. Once we choose the right region, we can now build our network. You'll type in VPC in the service search bar, and that'll bring up your VPC dashboard for this region. From there, you'll click your VPCs and then create VPC. Now we'll have a few settings to configure. We'll put in the CIDR block, which is 10.1.0.0/16, and the VPC name, which we'll say is app VPC. We'll leave the rest as default, and then we'll click Create VPC. Easy as that. Okay, Seth, what's next?
Nice, that was fast. After you create your VPC, you then divide the space inside the VPC into smaller segments called subnets. You put your resources, such as your EC2 instances, inside of these subnets. The goal of these subnets is to provide more granular control over access to your resources. So if I have public resources, like our employee directory app, that we want to be accessed over the internet, I could put these resources inside a subnet with internet connectivity. If I have more private resources, like a database, I could create another subnet and have different controls to keep those resources private. To create a subnet, you need three main things: the VPC you want your subnet to live in, which is this one, the AZ you want your subnet to live in this case, we'll choose AZA, or in other words, US West 2A, and then the CIDR range for your subnet, which must be a subset of the VPC CIDR range. For this, we'll choose the CIDR range 10.1.1.0/24. We'll call this our public subnet for public-facing resources. Then we'll create another subnet for our private resources. We'll place it in the same AZ, specify a different non-overlapping CIDR range, say 10.1.3.0/24, and then name it our private subnet. All right, now that we've got two subnets added to our VPC, it's time to put Morgan to the test again and have her build these out. And this time, I'm timing her.
All right, we're on a time limit here, so let's create these subnets. Let's go ahead and start creating the public subnet. Back in the console, we'll click on Subnets in the side panel and then select Create Subnet. Then we'll select the VPC we're working with. In this case is App VPC. Once you do that, you'll be prompted to provide a name. We'll say this one is Public Subnet 1. Then we'll choose the AZ, which Seth mentioned was US West 2A, and then the CIDR range will be 10.1.1.0/24. We'll leave the rest as defaults, scroll down to the bottom, and click Add New Subnet. We'll now repeat the same steps for our private subnet. Give it a name, such as Private Subnet 1, put it in the same availability zone, US West 2A, and then type in the CIDR range, which is 10.1.3.0/24. Now we can click Create Subnet, and both subnets will be created. All right, Seth, what was my time?
That was so fast that my watch didn't even register it. Okay, moving on. As we mentioned earlier, when you create a new VPC, all the resources you put in it are isolated and only have access to other resources in that VPC by default. For websites like our corporate directory application, we want users to access our site over the internet. To enable internet connectivity, we need a component called an internet gateway. Think of this gateway as similar to a modem. Just as a modem connects your computer to the internet gateway connects your VPC to the internet. When you create an internet gateway, you then need to attach it to your VPC. If you create an internet gateway and don't attach it, it won't do anything except sit there. Okay, Morgan, show us how it's done. Create an internet gateway and attach it to our VPC.
Okay. Back in the VPC dashboard, you'll click on Internet Gateways on the side panel, then Create Internet Gateway. You'll give the Internet Gateway a name, and then click Create. On the Details page, you'll then select the Actions drop-down box and select Attach to VPC. Choose the app VPC we've been working with, and then click Attach. Okay, Seth, what's next?
Sorry. I thought I'd have more time to drink my tea. So we have an internet gateway that we can use to allow access from the internet. But what if we had a VPC with all internal private resources that we want to reach only from our on-premises data center? If we only want traffic to flow between AWS and our data center, and we don't want to allow direct access from the internet, what do we do? Luckily, there's another gateway designed for this very purpose, called a Virtual Private Gateway, or VGW. It allows you to create a VPN connection between a private network, like an on-premises data center or internal corporate network, to your VPC. With the help of a VGW, you can establish an encrypted VPN connection to your private internal AWS resources. We won't be using a VGW for our application, but it's good to know. We'll talk more about that in an upcoming lesson. All right, so we have one VPC, two subnets, and an internet gateway. Now, every time you look at an architecture, you should begin to think, how do I make this better? You're not going to have all of the answers right away, but I do want you to take 10 seconds and think about some solutions. Well, one option to make this better is the idea of having high availability. What that means is if this AZ goes down for whatever reason, what happens to our resources in that AZ? They go down too. So ideally, we would have resources in another AZ to take on the traffic coming to our application. To do this, we'd need to duplicate the resources in the first AZ to the second AZ. So that means we'd need to create two additional subnets, each within another AZ, say AZB. As a best practice, you should always be using at least two AZs and hosting your resources redundantly. Morgan is going to build out some subnets in another AZ in the background for the rest of our demos. She's also going to launch an EC2 instance hosting our application in one of the public subnets. Sound good, Morgan?
Sounds good. Okay, we'll see you in an upcoming video, this time with one VPC, 4 subnets across 2 AZs, and 1 running EC2 instance.
Let's take a look at our current VPC state. In the last video, we left off with a VPC with an internet gateway attached to it, and 2 subnets, 1 public, 1 private, and 1 availability zone. However, Morgan was kind enough to build additional resources in the background to make sure our application was highly available. So now we have 2 additional subnets, 1 public, 1 private, in a different AZ for a total of 4 subnets. She also created an EC2 instance hosting our employee directory inside of the public subnet in AZA. But we're missing one large component here. Say we have a user and that user wants to access our employee directory. Eventually, that internet traffic would flow through the internet gateway, but then where would it go? Just because the traffic entered through the door of the VPC, it doesn't mean it ever made it to the right room. What we need to do is to provide a path for the internet traffic, not only to enter the door, but also make sure traffic reaches the right room. Or in other words, enter the internet gateway and then find the right subnet. The way we provide that path is through route tables. A route table contains a set of rules called routes that are used to determine where the network traffic is directed. These route tables can be applied at either the subnet level or at the VPC level. When you create a brand new VPC, AWS creates a route table called the main route table and applies it to the entire VPC. AWS assumes that when you create a new VPC with subnets, you want traffic to flow between those subnets. In the last video, when we talked about VPCs being isolated, this is what we meant. The default configuration of the main route table is to allow traffic between all subnets local to the VPC. Let's get a quick look at the main route table of the VPC we just built out in the last video. For that, let's get Morgan out here.
Hey, I understand that you want to take a look at the main route table for the VPC.
That's right. Can you walk us through that?
Yeah, let's go ahead and take a look. In the VPC console, we'll click on Route Tables on the side panel, and it will bring up all of the route tables that exist in this region. If we scroll to the side, we can see the main column and the VPC column. We're going to look for the main route table for the app VPC, which is this one. When we click on it, we can bring up the bottom panel and then click on Routes. Here we can see the local route that has the destination of the VPC IP range. This means that all of the components inside of our VPC can communicate with one another locally by default. This local route will be present in every route table that you create. All right, that's the main route table.
While the main route table controls the routing for your entire VPC, you may want to be more granular about how you route your traffic to specific subnets. Remember when we mentioned that subnets can be used to group your resources together based on whether they are publicly or privately accessible? Well, the subnet itself doesn't provide that access. Whether a subnet has access to the public internet or not depends on its associated route table. If a route from the internet gateway to the subnet exists, it has public access. If the route table doesn't have a route between the subnet and the internet gateway, then it doesn't have public access. So we call subnets public or private, but it's really the route table that provides that access. So for your subnets, you'll create custom route tables. Inside these custom route tables, you'll have that default local route inside of it that allows traffic to flow freely within the VPC, but then you'll need to create additional routes. So the subnet with the internet-facing resource, in this case our EC2 instance with the employee directory website on it, will need a route to the internet gateway. So that means, Morgan, we need your help again. Do you mind creating a custom route table and associating it to our public subnet?
Sure can. Let's get started. Let's create the route table for our public subnet. Back in the VPC console, once again, we'll click on Route Tables on the side panel and then Create Route Table. We'll give it a name, such as app-route-table-public, choose the app-VPC, and then click Create. Our route table has been created, but we're not done yet. We still have to edit the routes to allow traffic to flow from the internet gateway. To do this, we'll click on the ID of the route table and then go to the route section in the bottom of the summary table. We'll click Edit Routes, Add Route, put 0.0.0.0/0 for the destination, meaning it can take and deliver traffic from anywhere, and then specify the target as an internet gateway. This will bring up available internet gateways to attach it to, and from here we'll select the app IGW. We're done with the routes, so we'll click Save. But how do you know which subnet this route table applies to? Well, we have to configure that. If we only want this route table to apply to our public subnets, we'll need to associate it with our 2 public subnets only. To do this, we'll click on the Subnet Associations tab, select Edit Subnet Associations, and choose the public subnets we created earlier. Then click Save. All right, we've hooked up our public subnets to a route table that allows internet traffic from the IGW to our employee directory application. If we wanted to create a route table for the private subnets, we would follow the same steps. create the route table, make sure there's no route to the internet gateway this time, and then associate it to the private subnets. Okay, now we've configured a route to the internet gateway, and we'll configure additional firewall rules later on.
Nice. So this is our final state of the diagram. 1 VPC, 4 subnets, 1 public, 1 private in both availability zones. Our 2 public subnets are associated with a route table that allows traffic from the internet gateway. Our private subnets don't have a route table associated to them yet, so they follow the rules of the main route table, local traffic only. Now we have a complete network that enables internet traffic flow to our public subnet. But how do we know it's secure? Well, at the base level, we know that any new VPC is isolated from internet traffic, so that prevents risk. But when you start allowing internet traffic by opening up routes, you need other options to keep your network secure. In AWS, you have 2 options to secure your VPC resources: network access control lists, often referred to as network ACLs, and security groups. We'll start with network ACLs. You can think of a network ACL as a firewall at the subnet level. With network ACLs, you can control what kind of traffic is allowed to enter and leave your subnet. So, if I were to draw network ACLs in our diagram, they are placed around each of our subnets by default. The default network ACL allows traffic in and out of your subnet. Using this default configuration is a good starting place, but if needed, you can change the configurations of your network ACLs to further lock down your subnets. For example, if I only wanted to allow HTTPS traffic into my subnet, I can do that. I can create a rule in my ACL that allows HTTPS traffic from anywhere on port 443 and denies everything else. However, just because I allow inbound HTTPS traffic does not mean my job is done. If I don't open up the corresponding outbound port used for the protocol, then that means the traffic is allowed in, but the web server's response will never leave the subnet. This is because network ACLs are considered to be stateless. I need to include both the inbound and the outbound ports used for the protocols. What that means for our HTTPS example is that I need to allow outbound HTTPS traffic from the subnet to the internet by creating an outbound rule. The other security feature is security groups. These are firewalls that exist at the EC2 instance level. Security groups are not optional, so anytime you create an EC2 instance, you need to place that EC2 instance inside of a security group that allows the appropriate kinds of traffic to flow to your application. In our diagram, if I were to draw security groups, I would draw them around every EC2 instance in the VPC. In our case, we simply just have one EC2 instance, so we would need a security group around that instance. You know what? I think it's time for a demo. Let's get Morgan back in here.
Hey, Seth, what should I demonstrate next?
Do you have some time to build out a security group for our employee directory application? I think we need an example.
Sure, let's get started. The default configuration of a security group blocks all inbound traffic and allows all outbound traffic. If you want your EC2 instance to accept traffic from the internet, you'll need to open up inbound ports. If you have a web server, you may need to accept HTTP and HTTPS requests to allow that type of traffic through your security group. You can create an inbound rule that will allow port 80, HTTP, and port 443, HTTPS, as shown here. The beauty of security groups is that I don't have to open up an outbound port for traffic to be able to leave the instance. Security groups are considered to be stateful resources. They will remember if a connection is originally initiated by the EC2 instance or from outside and temporarily allow traffic to respond without having to modify the inbound rules. All right, is that everything?
That's it for this one. Thanks. Remember that security groups and network ACLs are powerful tools to filter network-wide traffic for a single instance or subnet's traffic. With security groups, everything is blocked by default, so you can only use allow rules, whereas with network ACLs, everything is allowed by default, but you can use both allow and deny rules. These configurations are largely up to you. For example, if you want ultimate convenience, you can leave the network ACLs in the default configuration and use mainly security groups to restrict access. We'll be doing just that with our employee directory application, and it will still be secure. But if you want an added layer of security, you can configure your network ACLs further for more fine-grained control. The solution we are building out with the employee directory application is an all-in cloud, meaning that the components needed to run and operate the application will be in AWS. However, many solutions require a hybrid model to be followed, where some components are in AWS and others are hosted in an on-premises data center. Let's take some time to talk about connectivity to AWS for hybrid deployments. For hosting your resources in AWS, you would use a VPC, which you learned about in the previous lessons. For hosting resources on-premises, you'd have your own solutions in an on-premises data center. So, for connectivity to AWS, how will you connect the remote data center to AWS? Let's talk about a few choices you can pick from where you're looking at connectivity between AWS and a remote site like a data center. First, let's talk about AWS Virtual Private Network, or AWS VPN. VPNs are a really common and popular way to securely connect your remote network to AWS. AWS VPN consists of two different services, AWS Site-to-Site VPN and AWS Client VPN. AWS Site-to-Site VPN is used to connect a remote network like a data center to a VPC. This would allow resources living in a customer-managed data center to connect to AWS. Then there is AWS Client VPN, which is more for connecting your administrators to AWS or to your data center. So this is more like when you need to log into a VPN on your laptop to access corporate resources. Using AWS VPN, you can connect to your VPC through the Virtual Private Gateway, which we covered in an earlier video. Just like the Internet Gateway is the doorway to the Internet, the Virtual Private Gateway is the doorway to your private data center through a VPN connection or through another service called AWS Direct Connect. AWS Direct Connect is a service that provides a hosted private connection to AWS through a Direct Connect delivery partner or through AWS. Direct Connect provides a private, dedicated connection. This isn't using the regular open internet to send data between point A and point B. While the data sent over Direct Connect is in transit, the network traffic remains on the AWS global network and never touches the public internet. This reduces the chance of hitting bottlenecks or unexpected increases in latency when compared to a VPN connection. AWS Direct Connect supports a larger and more reliable throughput. If you plan to send a high volume of traffic to AWS and you do need reliability in throughput for this connection, AWS Direct Connect would be a good choice. It really depends on your use case which one you would use. Or in some cases, you may use both where VPN is a failover for Direct Connect. Now, let's get back to building the employee directory application.
Hello everyone, in this video we are going to create a VPC, create 4 subnets, create a route table for the public subnets, and then we will attach an internet gateway to the VPC and then relaunch the employee directory application in the new VPC. So you can first see that I am in the VPC dashboard here, and I'm going to click on Create VPC. Now I want to select, this is a wizard that's going to help you create your VPCs, your subnets, things like that. I'm going to create just the VPC for now. So I'm going to select VPC only, and then I'm going to give this VPC a name. Let's call it App VPC. And then I want to enter in the CIDR range for this VPC. So to do that, I'm going to give the CIDR range to be 10.1.0.0/16. And then I'm going to scroll down and click Create VPC. Now we have our VPC. The next thing that I want to do is to create the subnets. So now I'm going to select the subnets on the left-hand navigation, and then I'm going to click Create Subnet. And then we'll select a VPC for this, and we will select the VPC we just created, app VPC. And now for our first subnet, we'll give this a name, public subnet 1, and then we'll select the availability zone, which will be US West 2A. And then we'll give this a CIDR range, which is going to be 10.1.1.0/24. And then we can go ahead and add our next subnet. So we're going to have a public and a private subnet in each availability zone. So we'll create our private one next. So private subnet 1, availability zone, same one, US West 2A. And then providing the CIDR range, we'll say this is 10.1.2.0/24. And now we can add our subnets into the other availability zone. So this one is going to be public subnet 2. And let's say this time we want to put it in US West 2B. And then for the subnet range, we can say 10.1.3.0/24. And then finally, we'll create one more subnet, which will be our private subnet 2. And then selecting the availability zone, we'll say is US West 2B. And we'll give this the CIDR range of 10.1.4.0/24. So you can see that we have, if I scroll back up to the top, you can see we have 4 different subnets being created with non-overlapping CIDR ranges. All of those CIDR ranges being a subset of the CIDR range that we created for our VPC. So we have 10.1.1.0, 10.1.2.0, 10.1.3.0, and 10.1.4.0. All right, now we can go ahead and click Create Subnet, and that will create all 4. All right, so now we have 4 subnets, public subnet 1 and 2 and private subnet 1 and 2. Next, what I want to do is create an internet gateway. So I will select Internet Gateways in the left-hand navigation and then click Create Internet Gateway. We'll give this a name. Let's say it's App IGW and then click Create Internet Gateway. Then we can go back to the Internet Gateways page where we can view all of our Internet Gateways. We currently have one Internet Gateway attached to our default VPC. What we want to do is select the new Internet Gateway that we just created, and we want to attach this to a VPC, and then we'll select our app VPC, and then click Attach to Internet Gateway. For Internet Gateways, and one Internet Gateway can only ever be attached to one VPC. So it's a one-to-one relationship there. All right, next what we need to do is configure our route tables. So to do that, I'm going to click Route Tables in the left-hand navigation. You can see that we have 2 route tables already. We have the main route tables for both of our VPCs, our default VPC and our app VPC, which we can scroll to the right and expand this and read that VPC there for our app VPC. So now scrolling back over, I'm going to click Create Route Table. And then we'll give this route table a name. We'll say Public Route Table. And then I want to associate this with our app VPC and then click Create Route Table. So now we have a route table that's been created, but we want to now add a route that will allow any subnet that has this route table associated with it. We want to add a route that will allow traffic from the internet 0.0.0.0/0 to where? The internet gateway. And the internet gateway, we want to choose the one that we just created, and then we'll click Save Changes. Now scrolling back down, we are not done yet. Now what we have to do is associate these subnets with this route table. So I'll click Subnet Associations, and then scrolling down, we can see we currently have this associated with no subnets. I'm going to click Edit Subnet Associations, and then I'm going to select our first 2 public subnets only. So there's nothing inherently about a subnet that makes it public or private. The only thing that makes it public or private is whether or not it has a route table association that includes a route from that subnet to the internet gateway. All right, so we'll go ahead and click Save Associations here. And then we can scroll back down, click on the Subnet Associations tab, and we can now see that we have our 2 public subnets associated with this route table. And then again, reviewing the routes, clicking back on the Routes tab, we can see we have our local route and we have our route to the internet through the internet gateway. So now the last step here is let's go ahead and relaunch our employee directory application. So I'm going to navigate over to the EC2 console. And then from here, I'm going to click on the instances link, which we can see that we have our employee directory application still running. And if I select this, I can scroll down and I can see where this is running, which is our default VPC. So what I'm going to do is I'm going to keep this checked, and then I'm going to select actions and then image and templates. And then I want to select launch more like this. And what this does is it brings you to a page that has a lot of the configurations for that original instance pre-populated over here. So you don't have to go through and reselect all of the configurations. So we can see that we have employee directory app pre-populated. I'm just going to go ahead and call this employee directory app 2. We can see we have the Linux 2 AMI selected here. And we also have our T2 micro selected. For the key pair, we do have to select that we want to proceed without a key pair again. And then here under network settings, this is where we're going to make most of our changes. We're going to select the new app VPC that we just created. And then we're going to select what public subnet we want to launch into, public subnet 1 or public subnet 2. We're going to go ahead and select public subnet 1. And then we're also ensuring that this auto-assign public IP is set to enable, which it is. Now, scrolling down, you can see that we can select our security group. Currently, we have the security group that was created previously associated with this instance, and it's giving us an error saying that we can't use the security group with this subnet. That's because the security group is tied to the VPC. So we need to create a new security group that will be associated with this new VPC, not the default VPC. So what we want to do here is click Create Security Group, and then we will leave the default for the name, and we'll do the same thing that we did when we created our original security group, which is we want to allow both HTTP traffic on port 80 from the internet, and adding a second rule, we want to allow HTTPS traffic on port 443 from anywhere. Now scrolling down, we can scroll down to the advanced details and expand this here. We can see that the role has been pre-populated, so that's great. And then if we scroll down some more, let's take a look at that user data. We can see that this also is pre-populated. So now we can click Launch Instance. We can click on the instance ID, see that this is in the pending state. And so now we'll wait a few minutes and come back and try to access it through this public IP address. And if we can access it, that means that all of our network configurations were configured correctly. Okay, so now we are back and we can see that the instance is in the running state. If we copy this IP address, and then I'm going to paste it into a new tab off screen, drag this tab over, we can see that we can now access the employee directory application at the IP address of the new instance that was launched into our new app VPC.